Salts. We know salt most commonly as table salt or sodium chloride, but in nature there are actually many different salts. All salts have one thing in common. They're made up of a positive metal ion and a negative ion. Salts are present in items like batteries, explosives, and fertilizers. They're also present in multivitamins. Calcium, magnesium, and iron are all present as salts in the multivitamin tablets. You'll also find salts in blood. Salts form in acid-base neutralization reactions. Here we have a neutralization reaction. All neutralization reactions are the same. An acid plus a base react to form salt and water. In this case, hydrochloric acid, HCl, reacts with sodium hydroxide, the base, NaOH, and it produces the salt sodium chloride and water. A salt always contains a positive ion from the base, shown with the yellow arrow, and a negative ion from the acid, shown with the green arrow. The leftover items, which are always hydrogen and oxygen, result in water. So in a neutralization reaction, an acid plus a base produces salt and water. Here are some more acid-base neutralization reactions. This is the one we just looked at. You can see in each one there's an acid, a base, a salt being formed, and water. Same thing with this one. This is acetic acid, which is vinegar. If you combine that with a base, they react to form salt and water. Metal oxides. Metals react with oxygen to form oxides. An oxide is a chemical compound that includes at least one oxygen atom or ion, along with one or more other elements. Here's an example. Na2O is a metal oxide because it contains a metal and oxygen. A metal oxide is a chemical compound that contains a metal chemically combined with oxygen. When a metal oxide dissolves in water, the solution becomes basic. Here are some examples. The metal oxide, sodium oxide, reacts with water to produce sodium hydroxide, which is a base. Here's another one. The metal oxide, calcium oxide, reacts with water to produce the base calcium hydroxide. Interesting little tidbit about metal oxides and their relationship to bases. There are also non-metal oxides. Non-metals also react with oxygen to form oxides such as carbon dioxide and sulfur dioxide. A non-metal oxide is a chemical compound that contains a non-metal chemically combined with oxygen. Here's an example, sulfur dioxide. You can see that sulfur is a non-metal and oxygen is a metal. When non-metal oxides dissolve in water, the solution becomes acidic. We can see that in all of these reactions. Let's look at the first one. Sulfur dioxide, the non-metal oxide, reacts with water to produce an acid. Okay? So each one of these basically shows you the same idea. Let's look at the one at the bottom. Carbon dioxide reacts with water to produce carbonic acid. All of these reactions have something in common in that they all contribute to acid rain. Each one of these acids can be a component of acid rain, and what happens is when these pollutants end up in the air, they react with water vapor in the atmosphere and produce these acids that fall back to Earth as acid rain. And acid rain damages lakes and soil by changing the pH to too acidic of a pH, too low of a pH for life to be able to exist in them. Acid rain also damages buildings, particularly limestone buildings, and this tends to happen a lot in eastern Canada. I'll explain why a little bit later in the video. Acids and metals. The most reactive acids appear on the extreme left of the periodic table. Alkali metals and alkaline earth metals react vigorously with water and also with acids. You may recall we did the lab where we put the calcium in water and we collected hydrogen gas. When an acid reacts with metal, the byproduct is hydrogen gas. And as you know, hydrogen gas is quite explosive, and so we were able to trap it and then ignite it, and we got it pop. The further down you go, the more reactive the metals are with acid, and so if you used something like cesium instead of calcium, you'd actually get more than a pop, you'd get a bang. Other metals, such as copper, silver, gold, and platinum, are very unreactive with acids. For example, gold will react only in a mixture of concentrated nitric acid and hydrochloric acid. Neither acid alone can dissolve gold. And so it gives these metals have unique properties then. So let's take a look at one of these reactions. Hydrochloric acid reacts with magnesium to produce magnesium chloride, a salt, and also that hydrogen gas that goes pop or bang. Sulfuric acid will react with aluminum, the metal, to produce a salt, again, aluminum sulfate and hydrogen. Acids and carbonates. Okay, so here's what an acid-carbonate reaction looks like. We've got the acid sulfuric acid reacting with calcium carbonate, and we get a salt and water. This is almost like an acid-base neutralization reaction, except you get one more thing here. You get carbon dioxide. And so when you put an acid on limestone or on any of the carbonates, you'll actually see a fizz, and the fizz is carbon dioxide gas being given off. It doesn't matter which acid you use. If it reacts with a carbonate, you're still going to get a salt and water and carbon dioxide with all those fizzy bubbles being formed. Much of the carbon dioxide on the surface of Earth is trapped in rocks such as limestone, dolomite, and calcite that contain carbonate ions. When carbonate rock reacts with acids, the carbonates help to neutralize the acid. Many lakes in Western Canada are located in rocky areas that have limestone deposits and so can neutralize much of the acid precipitation that falls on them. However, many lakes in Eastern Canada do not have carbonates in them and are more easily damaged by acid precipitation. We're lucky that we live in a mountainous area here in British Columbia that has a lot of calcium carbonate deposits, and the way that happened is that the sea creatures that lived millions of years ago, when they died, their shells, which are made of calcium carbonate, were left behind, and due to plate tectonics, the limestone deposits were pushed up to what are now the mountains of British Columbia.